convert some forms. You've done a little bit of this where you have taken things in standard form. You've used Desmos to help you rewrite it in Vertex or factored form. We're going from Vertex and factored form into standard form today. So that's where we're going. Okay, so with your notes out in front of you, this is what you should be writing down. You're going to put this equation on your piece of paper and you're going to follow along with me on this one. So I'm going to write it in the CamiDoc. So if you need to switch from your Pear Deck to my screen, and Mr. Wetzel, can you see my screen?
I can, yes.
Okay, so you see it as the CamiDoc?
Yep.
Perfect, okay. So switch over to your Google Meet so that you can follow along with me. Again, hopefully you have this written down. So we're going to take this equation in Vertex form and we're going to convert it to that standard form. Remember that standard form is that ax squared plus bx plus c. And all we're going to do in order to make this happen is we're just going to multiply this out. We're going to follow our order of operations and we're just going to get rid of the parentheses. That's all. So if we follow order of operations, we know anything with exponents and parentheses come first. We can't do anything with the two terms in parentheses, but we certainly can square them. Remember that a square means that we're using that x minus 2 twice.
And guys, pay attention. See how Miss Ray is writing everything out. She's not trying to shortcut steps. Take the time to write it out. It's going to help you.
Now, depending on how you learn how to multiply binomials, we have a couple of options. So I'll do this one way, this way, and then the next example I'll do it using what's called a box method. So here I'm going to use the distributive property. So if I'm multiplying two polynomials together, I'm going to distribute by multiplying that x to each term. So x times x gets me x squared. And then x times negative 2 gets me negative 2x. Then I've got to distribute the negative 2 to both terms inside that second parenthesis. Negative 2 times x is another negative 2x. And negative 2 times negative 2 is a positive 4. Most often in these problems, you will have some like terms. These are my like terms. So I've got x squared minus 4x plus 4. So I'm going to put this right where that x minus 2 happens to be. And a nice little review from Algebra 1, how to multiply some polynomial functions. Now we're about 2 steps away from converting this into this form where there are no parentheses. Next I'm going to distribute the 3. That 3 is going to get distributed to each term inside. Not to the plus 4 outside because the plus 4 is not in the parentheses. So that gets me 3x squared, a negative 12x, and a positive 12. The plus 4, still here, we haven't done anything with it. And now my final step, if I've got any more like terms, and I do, I'm going to combine those together. And I get 3x squared minus 12x, and that gets me 16. Now, you can always double check yourself. It's one of the cool things about this is take this equation that you just wrote, type it into Desmos, take the original function, type it into Desmos, and make sure they are the exact same graph. If they're the exact same graph, chances are you are completely correct and you have switched from Vertex form to standard form. Okay, so now what I want you to do, I want you to try that one on your own. All right, so here we are. So switch to my Google Meet so you can watch. So we've got ourselves, what number is in front of that parentheses? -1. So Colin's got it. There you go, -1. So make sure we know that that's there. That's our A value. That A value is going to be the same A value that is going to be in our standard form equation. So if I rewrite this, I'm going to make it -1, x plus 5, x plus 5. And this is where I'll show you the alternate way to multiply. So if you want to multiply x plus 5 and x plus 5, you can use what's called the box method. I'm a personal fan favorite of the box method. I make a box based on number of terms that are in each polynomial. There are 2 terms here, 2 terms here, so I'm going to make a 2 by 2. That's a terrible looking box. A 2 by 2 box. I've got a very slanted box here in my my cami here. Let's see if I can straighten it up. Each term goes on the outside edge of the box, signs included, so since everybody's positive. And now we just multiply row to column. This row and this column gets me x squared. Row column gets me 5x. Row column, row and column. And then once I have my multiplication, I'm going to write the terms in order, highest degree. Anything that's a like term, we're going to add together.
Hey, Miss Grant.
Uh-huh.
For Vertex standard form, can you still do the other method?
You mean the distributed property?
Yeah.
Yeah, absolutely. I'm just showing you another way to multiply. Some people like the box, some people like the distributive property. I do not care which one you choose to use. Use the one that speaks to you the best. So I'm going to replace this with that x squared plus 10x plus 25. Now notice I've kept it in parentheses, and I've had to keep it in parentheses because I still have something that needs to be multiplied on the outside of it. So now I'm going to distribute this. That -1 gets distributed to all terms inside the set of parentheses. And that will get you -1x squared, -10x, -25. And then the -2 is still there. Final step is to add together any of those like terms. So I've got -1x squared minus 10x minus 27. And there is my equation multiplied out from vertex form to standard form. And again, you can put it into Desmos and see if they match up. And that's how you'll kind of check your answer. All right, I've got another one for you to try. I'm going to switch back to your Google Meet. You can watch.
So with the box method, I got like 6x, you have both 6x's together?
Yes.
Okay.
Yes. All right, so let's take this. I'm going to deal with this x minus 6 first. Again, it is your choice. Do you want to do the box? Do you want to do the distributive property? I don't care. Whichever one speaks to you. Now be careful though. Notice that's a -6, so take the sign with it if you're going to do the box method. That's one of the places where students make little mistakes. So that gets me x squared, -6x, a -6x, and a positive 36. So these are like terms, so when I write out the answer, I'm going to add those together to get me a -12x. Okay. All right. So f of x equals a half. I'm going to take that x squared minus 12x plus 36. And then I'm going to distribute. And a half's not a bad one to distribute. So a half times 1 is just going to be a half x squared. And we know what a half does. We know that's going to make our parabola wider. Half of -12 is going to be -6. Half of 36 is 18. And then our last step, combine those like terms. So my standard form equation, 18, 19, 20, 21, 22, 23. Yep, that's right. I'm going to use those fingers to count. And if you disagree with my answer, don't ever hesitate to question me because, yes, I do make mistakes too. Okay. All right. Your next Example, this is not for you to answer, this is for you to watch. So let's write this equation down. And I think you're going to find factored form to standard form about the same as what we just did. The good news is you don't have to rewrite any type of multiplication because it's already rewritten for you. All right, so we're in factored form, and I recognize factored form because I've got two sets of parentheses. So right away, I hope you realize, hey, let's just take these two things and let's multiply those polynomials together. So again, distributive property or box, it's your choice. I'm going to distribute in this one. That's going to get me x squared. That's going to get me a positive 5x. Negative 4, so watch those signs, times x. And negative 4 times 5 gets you negative 20. Chances are you'll have some like terms. Now, if you're like a lot of students, you're going to get to this point and be like, woohoo, I'm done. But we can't forget the 2. So it's probably a great practice to put the 2 and keep the 2 on the outside of the problem the whole way until you're ready to distribute him. So you don't forget to take the 2 into consideration. So now we take the 2 and we distribute. And again, we know we're in standard form when I don't see any parentheses. Again, all I'm doing is doubling all my terms. And I am in that standard form x squared all the way down to the constant. Happy bubble cloud of math joy. And we have one for you to try. So one, and then get you guys out of here. So, I need a new color. Whatever, that blue, we'll work with that blue. Okay, so going to multiply this out, I'm going to use the box method. I'm going to notice, though, that there is a negative 1 in front of this. So whatever I do here, my final step will to be multiplied by a negative 1. So I have that minus 7. X times x is x squared. That gets me 2x, bless you, negative 7, negative 14. Most often your diagonals are your like terms. So I get x squared minus x, 5x minus 14. So I'm going to bring that over here with that negative 1 out in front of parentheses, because that negative 1 then has to be distributed to all terms inside. So give yourself a pat on the back if you've got negative 1x squared, positive 5x, and positive 14 as your final answer for this equation in factored form to standard form. Cool.
And again, in Desmos, you can check by putting both equations into Desmos and seeing if you have a match.